We've been working with quadratics and writing them in equivalent ways such as factoring, and we've seen that these ways of rewriting quadratics, they have a purpose. Like maybe I could see the y-intercept in one form, or I could see the x-intercepts in another form, or I could see the vertex in another form. So we've seen this thing called vertex form, and in this video we're going to see how you can rewrite a quadratic to get this vertex form. And so as a clue to start, we're going to look at a perfect square. We're going to multiply out x minus 3 squared. So I'm going to set it up like this as a square, x minus 3 and x minus 3. So that will be x minus 3 squared once I multiply it out. So I'd have x times x to get x squared. This will be minus 3x because it's x times minus 3. Same thing here. And this will be positive 9 because negative 3 times negative 3 is positive 9. So I would get x minus 3 squared is equal to x squared minus 6x plus 9. So there's some clues built into this that we're going to use as we move forward. So one question I asked is, well, what if I subtracted 4 from this output? So maybe I subtract 4, so the 9 becomes a 5. Wouldn't you get x minus 3 squared? If I subtract 4 from this side and I did it from this side, I would get x squared minus 6x plus 5. So that's the clue we're looking at. If we started with that, if I started with x squared minus 6x plus 5, could we work backwards to get x minus 3 squared minus 4? That's where the subtracting of 4 came in. And yes, we could. Let's do it. Okay, so one observation that we need to make, one pattern here, is if I started with x squared minus 6x plus 5, it's related to this. And the minus 6x showed up in my box as minus 3 and minus 3. It was exactly cut in half. It was exactly cut in half. So let's start there. Let's start with this and say, okay, if I take my middle term and I cut it in half, I would get x minus 3, x minus 3. I would be exactly where I started with. I'd have x squared minus 3x, and plus 9. And then I would look at my 9 and say, but I want a 5. So that's 4 too large. I have to subtract 4. To go from 9 down to 5, I have to subtract 4. So I would say this is x minus 3 squared, and I was 4 too large, so I do minus 4. Let's apply this thinking on a couple more. 2 more, and then you'll get to try some to practice. So if I'm going to have any hope of writing this as a perfect square, to write this in this vertex form, I'm going to take my middle term and I'm going to realize that it had to be cut in half. So I take my box. I know that 8x has to be a 4x and a 4x. So I had x plus 4 and x plus 4, and that got me what I was looking for. So this is going to be a 16, because 4 times 4 is 16. To go from 16 to 18, I have to add 2. So this is going to look like x plus 4 squared, because this is x plus 4 times x plus 4. And if I stopped there, I'd have a 16 for my last term, but I want an 18, so I have to do plus 2. And that is vertex form. One more. I'm going to take my middle term and cut it in half. So I'm going to have a minus 7x and a minus 7x. Minus 7x. So I'm going to have x minus 7 and x minus 7. And then if this is a perfect square, minus 7 times minus 7 is 49. Well, I don't want 49, I want 47. So I'm 2 too large, because 49 minus 2 is 47. So this is x minus 7 squared minus 2. That should be equivalent to the original quadratic I started with. One nice thing about working with mathematical expressions is there's always ways to check that you're correct. Like, for example, I could plug in values for x into this expression, like plug in 0, and plug in 0 here and see if you get the same results, because my claim is that these are equivalent. Another way to do it would be to make a graph. So I went to desmos.com/calculator And I typed in the two equations that we think are equivalent. And if I click on this, I can see the graph of this quadratic show up. And I think that this one is equivalent. So when I click on it, you'll see that it became blue, and it's the exact same thing. It just plotted over the exact same curve. And so we got it correct. The blue and the red are equivalent, because as I turn them on and off, they just cover each other. And the claim was that we could see the vertex in this vertex form. And the vertex here is the lowest part of the quadratic. It's 7, negative 2. And I can see that in this form. There's my 7, and there's my minus 2. So that's why this is called vertex form, because in this form, I can very quickly see the vertex of the quadratic, which is usually a very important point. So there should be a few more for you to try now to be able to rewrite a quadratic expression in vertex form.